Fluorophores are chemical tags that bind to a specific molecule, often via an antibody, and emit a measurable light signal that can be used to quantify that molecule or analyte. Accurate detection of analytes using fluorophores can be complicated. Other molecules commonly present in biological samples may also emit light signals, and there is no clear way of distinguishing fluorophores bound to the analyte from those that are not. One solution is to wash away confounding molecules before taking measurements. The additional processing steps, however, mean longer time to result, more waste, and greater room for error. Another solution is to lengthen the light emission of a bound fluorophore to outlive the signals of other molecules in a sample and then record only the signal of interest. This is the solution of time-resolved amplified cryptate emission, or TRACE. The key to TRACE technology is europium cryptate. Triggered by light, europium cryptate emits a long-lasting light signal. When cryptate and a fluorophore bind to the same analyte to form an immune complex, energy transfers to the fluorophore, which dramatically lengthens its signal. Cryptate, fluorophore, and the sample are simultaneously pipetted into a reaction well. When triggered by light, formed immune complexes and unbound cryptate emit long signals simultaneously with other short unspecific signals. Detection is delayed 50 microseconds so that only the two long-lasting signals are recorded. These occur at different wavelengths, so the immune complex signal is easy to isolate. No washing, no additional steps, no additional waste. Signals from immune complexes and unbound cryptate are affected equally by differences in light transmission through a sample. Thus, the ratio of the two signals remains constant and is an accurate measure of the presence and amount of analyte, regardless of the optical quality of the sample. Quenching or other effects that impact quantification are not an issue. Multiple detection events spanning the reaction incubation period determine early on if a reading is out of range. The identified sample can then be diluted and retested to avoid false negatives due to high analyte concentration. With elegant chemistry, TRACE technology eliminates hurdles in analyte quantification. Detection is fast and accurate, taking place upon mixing sample and reagents. No additional processing is needed to remove confounding signals, which means less waste and faster time to result. Finally, quantification is not impacted by sample characteristics, and repeat measurements enable early decisions to dilute out-of-range samples. TRACE technology simplifies your workflow and delivers answers you can trust.